right, this is an example of us wanting to isolate x. We start with 3x equals 13. Now, in order to isolate x, we have to know what is being bonded to it. So in this case, we have a 3 that's bonded. And the way that what we look at is we have it's 3x. Now, we don't see any addition. We don't see any subtraction. We don't see any multiplication signs. We don't see any division signs. Okay, so how do we know how it's bonded? Okay, so anytime we see a number directly next to a variable, we know that it is being multiplied. Okay, multiplication does not always need to have a multiplication symbol. We say the same thing whenever we have a number directly next to parentheses or a number directly next to a bracket or a number directly next to a root. Anytime the number is directly next to something, whether it be a variable, some sort of grouping, or a root, anything like that, we know that it is being multiplied. Now, back to our original problem. We know that 3 is being multiplied by x. So we want to isolate x. Okay? Now, in order to do that, we have to remove whatever kind of bond it is. Now, we know that it's being multiplied, but so in order to get rid of it, we have to do the opposite. The opposite of multiplication is division. So we are going to divide by 3. By 3 because we want to get rid of the 3. And that will cancel that out. And what we do to one side must be done to the other side. So x equals 13 thirds. Could we break this down further? Yes, we could also make it equal 4 and 1/3, but not always required. Typically with a problem like this, I will keep it in its improper fraction form.